Hello everyone and welcome to this video of Just Solved It. In this episode we will be solving an ODE using a numerical approach of the Heun's method. So we have this example, y prime is equal to x squared, where the initial value of y is 1. We have a step size of 1 and we'll be finding the value of y when we're at the point of 5 in the x-axis. The difference between the Heun's and the Euler's method is that the Heun's method is also known as the improved Euler's method. We have these three main equations or formulas rather. We have this for the value of x sub n plus 1. We have this y sub n plus 1 with the curve something above the y, which tells us that this formula is a predictor. And then we have this another formula which is the real value for the y sub n plus 1 in the Heun's method is known as corrector, where we will use the answer or the value we have got from the predictor formula. So let's move on to the steps. So we have steps 1 to 5. Basically we have a step size of 1. Therefore in every step, it near the equivalence of value of the actual value of x at that step. So for example here at step 1 we have the x sub 1 is equal to 1. So here the predictor we have 1 plus 1 times the f of 0 and 1. So we have x squared, therefore we will only use the value of x to substitute the value of x to the variable x in the x squared. So it's basically 0 squared, which is 0. So 0 times y 0 leaves us with the answer 1. So here at the corrector, y sub 1 is equal to 1. 1 is the initial value of y sub 0. Y sub 0. The value of y sub 0 or the initial value of y. So 1 plus 1 half times 0 squared plus 1 squared. So here we have this. So f of x sub n and y sub n plus f of x sub n plus 1 and the predictor y sub n plus 1 here. So deriving it, we have this value 1 plus 1 half times 1 is equal to 1.5. Repeating those steps across the step 2, step 3, step 4, step 5. If you need time to analyze the solution, you could pause the video. So at the last step, at step 5, we will be getting here that the y sub 5 is equal to 23 plus 1 half of 4 squared plus 5 squared. 23 plus 1 half times 16 plus 25. So 16 plus 25 is 41. 1 half of 41, and add it to 23, we'll get the value 43.5. So the 43.5 is the approximation for the value of y at the point 5 in the x-axis. This is a approximation, or also known as what I've said earlier, a numerical approach in solving ODE. And I think at this point, we have just solved it.